we've got a problem up on the board here. I want to just go over the directions here. The directions say use the binomial theorem to expand 2x plus 3 to the fourth. Now when I expand a power of a binomial, that means I'm going to multiply it out so that I can write it as just a simple polynomial, preferably in descending order. Okay. But I'm not going to do this by just multiplying out 4 factors of 2x plus 3, because the directions tell me to use the binomial theorem. Now, on your final exam, if the directions say use the binomial theorem to expand, and you ignore the directions and just multiply out 4 factors of that, you're not going to get full credit. You're going to get very little partial credit, because what I'll be testing you on then is the binomial theorem. I want you to know that because it does get used in calculus. And so that's why we're covering it this semester in pre-calculus. So I'm going to use the binomial theorem to expand this. And then I've added simplify fully, because we'll see, once I've applied the binomial theorem, there's actually going to still be some work to do. So I'm going to start by just writing out the types of terms that I have, leaving a blank for the coefficient, which I'm going to get, remember, from Pascal's triangle. So I know all of my terms are going to contain 4 factors, and each of those factors will be either 2x or 3. And I can start by having some terms where all 4 of those factors are 2x. So 2x to the fourth, no factors of 3. Plus, I could have some terms, and I'm going to systematically work my way down. Each time I'm going to have 1 less factor of 2x and 1 more factor of 3. So I could have some factors of 3 factors of 2x and 1 factor of 3. Plus some terms, 1 less power of 2x, so that's going to be 2x squared. So then I have 1 more 3, so that's 3 squared. Plus some terms where I have 1 less factor of 2x, so that would just be 2x to the first, and then I'd have to have 1 more factor of 3, so 3 cubed. Again, not necessary to write in when the power is 1, but I kind of like it because then I can double check. My exponents are always adding up to 4, so I always have a total of 4 factors. Okay. Plus some terms where now I would have no 2x's, and I would just have 3 to the fourth. So those are the types of terms I'm going to have. And now I need to fill in the coefficients. Now to do that, I use Pascal's triangle. So remember, we always start with 1, 1. Those are the coefficients I would have for a plus b to the first. I would have 1a and 1b. Okay. In this case, 2x plus 3 to the first would be 1 copy of 2x and 1 copy of 3. All right, we work our way out, and that's 2. That's my second row. Here's my third row. 1 plus 2 is 3. 2 plus 1 is 3. Fourth row is the one I want because we're looking at the 4th power. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. Now, it's possible that as you're doing the homework, you're going to write out Pascal's triangle enough that you sort of just remember what the coefficients are. I'm fine with you accidentally memorizing it, but I'm not fine giving you credit for that. I want to see you writing out Pascal's triangle on the exam so that I know where the coefficients come from. Okay. But now I can just fill them in. This is 1, 4, 6, 4, 1. And that's kind of a nice way of double checking that I got all of the types of terms I should have. The number of blanks I had for the coefficients matched the number of numbers I had in the 4th row here. Okay. So that's using the binomial theorem, but now I want to simplify fully. Okay. So that means I want to get each of these terms to just be a number times a power of x. So I've got a little bit of work to do. So here, multiplying by 1 won't do anything, but this 4th power applies to the 2 and to the x. 2 to the 4th would be 2 times 2 is 4, times 2 is 8, times 2 is 16. So I'm going to have 16 copies of x to the 4th. Plus, I'm going to just simplify each factor and then I'll come back and combine them. So I've got a 4 The exponent applies to the 2 and the x. 2 cubed is 8, and then x cubed. And then 3 to the first is just 3. Plus, here, 6 times 2 squared is 4, and then x squared. 3 squared would be 9. So when I have something more complicated than just an a or a b, if there are numbers involved, I have to actually evaluate the powers. Okay. So here, this is going to be 4. 2x to the first is just 2x. 3 cubed, that's 3 times 3 is 9, times 3 is 27. And then 3 to the fourth, I'm going to take 27 times another 3, and that's going to give me an 81. So now, that's 16x to the fourth. And here, I can just multiply out all of the numbers. So 4 times 8 would be 32, times 3 is going to be 96x cubed. Plus, 6 times 4 is 24, times 9 is 216 x squared, plus 4 times 2 is 8, times 27. Oh, that's interesting. That's also going to be 216, but now that's copies of x plus 81. All right. So that gives me 2x plus 3 to the fourth expanded. So I've expanded it and I've simplified each thing, so I've got just a number times a power of x. All right, I'm going to give you folks one to try. I want you to follow the same directions, but you're going to look at x squared plus 2x cubed. So your binomial has two terms. The first is x squared, the second is 2x. And you're taking that whole thing to the third power. So apply these same directions. Use the binomial theorem to expand it, and then make sure you fully simplify. And we'll go over that together in the next video.